Hello, today's video is going to be on inverses of functions and determining whether or not things are inverses. So if you'll just take a second to kind of read through this paragraph, we're going to look at inverse relationships. We already know some inverse relationships. For example, we know that multiplication and division have an inverse relationship. That means they undo each other. That's what inverses do. They undo each other. We're going to look at it in functions and specifically looking at graphs. We're going to be finding inverse functions as well as gaining an understanding of the properties of inverse relationships in functions. Okay, so to start off with, I have two images here that are depictions of inverse functions. That is, the solid line and the dotted line are inverses of each other. Same thing over here. This dotted line and this solid line are inverses of each other. So what I want you to do is, can you just take a minute to look at those graphs and write down in the space here one or two things that you notice about those graphs? And so pause it here and write down a couple things. You could have written down a variety of things. One thing you might have noticed is that they reflect over the line y equals x. So I drew that red line in there. That is the line y equals x. And maybe you didn't remember what the equation for that line is, but that is what the equation is y equals x. So one thing is you might have noticed that it reflects over that line. Or maybe that you said they are sideways from each other, something along those lines, which on this graph over on the right is a lot easier to see, and it doesn't really look as much that way on the left-hand graph. So one of those, you might have noticed that the x values and the y values are switched with each other. For instance, well, we'll go through right now and investigate that one, but you might have had a couple other things down there. Another thing about this video today is I've made a bunch of typos in our tables. And so this is our first typo. Here is this table. Can you take a second to correct this table? Okay, let's take a minute to continue with these graphs. First of all, this first table is going to be for the dotted line, and the second table is going to be for the solid line. And the same thing over here. The first table is going to be for the dotted line. The second line is going to be for the solid line. All right, on this example, we have a point here at 0, 0. We have a point, now notice that these graphs, I know they're hard to read on your paper, and so I do apologize for that, but notice they're counting by twos. This is 2, 4, 6, etc. So 1 is going to be right here, and if we go up 1, it is right about there, which is right about at the 1. 2 is here, and that goes over to here, which again, we're counting by 1 is over here. So that might be something like 1.4 approximately. I just figure it's not quite 1.5, so it's about 1.4. 3 is going to be here, so we go up to 3 and it hits here, and that might be something like 1.75. And 4 looks like it definitely hits there for 2. All right, those are the coordinates on the dotted graph. Let's look at it for the solid graph and see what we get. Well, once again, we have a 0, 0. On the 1, we also have a 1, 1. Now, I purposely made these kind of strange entries over here on the x column, but I think you'll see why. So if we go to 1.4 and we go up to here, we're going to hit right there, and that is right about at the 2. And then 1.75 is going to be here. We're going to go all the way up and hit right about here. We could say that is very close to 3. And 2, easier because there's a line to match it, and that goes to 4. Okay, so this is what I was talking about. Notice that the x values and the y values switch with each other. So 0, 0, 0, 0, easy. 1, 1, 1, 1, easy. But the next one, 2 and 1.4, well, over here it switches, 1.4 and 2. And then we have 3 and 1.75. Here we have 1.75, 3. And 4, 2 corresponds to 2, 4. Now that one, like I said, the tables work out just fine. Sometimes people think that's a little bit difficult to see, and so that's why I put this one on here. This one's a little bit easier to see, but it is going to make some confusion on our tables. So these aren't always easy to see in every aspect, whether it's the table, the graph, the equation, what have you. Okay, so for our dotted line, let's just go ahead and do this. For our dotted line, this time the boxes are counting by ones. So -2 looks like it goes up there pretty close to the 5. -1 goes here pretty close to about the 2. 0, 1, 1, 2. And once again, this is a parabola, so they ought to be repeating, and in fact they are repeating. But then if we go over to the solid line, this is where, like I said, it's going to get a little bit complicated, and we'll see why. Okay, because 1, well, that's easy. Good. 1, 0 is a point. 2, well, if we go to 2, there's actually 2 points. There's a +1 and there's a -1. And so we could say it's 1 and -1. And if we go to 5, it is both +2 and -2. Okay, the reason this is happening is because the original is a function, but as soon as we flipped it on its side, it is no longer a function. So that's why our table isn't working out, is it's not a function any longer. So this one is not a function, however, it is still the inverse. It's just not it's not a function. And so we will talk about what happens if one's a function and one's not, compared to if they are both functions. But for now, let's go on to these next couple of questions. What do you notice about the relationship between the table of the original and the table of the inverse? And we talked about that a second ago. The x values and the y values are switched. And if you think about it, what does that mean for the relationship between the domain and the range? Well, remember that the domain is your x values and your range is your y values. And so now if you've switched your x's and y's, doesn't that mean you've also switched the domain and range? Okay, so we've switched our domain and range as well. All right, remember when you have questions in the notes that you are to write them down in the margin. So when you come to class tomorrow, you can ask questions. So if there's any questions here, go ahead and write those questions down. And then after you've written down your question, we're going to go ahead and turn the page. Okay, so this is what I was alluding to a minute ago, is there's this concept called a one-to-one function. And another word for one-to-one function is also invertible. And I just bring that up because sometimes that word will appear on standardized testing, like maybe your MAP test or your ACT or SAT or state tests or what have you. Sometimes they use this word invertible. And the word invertible means, is it one-to-one? In other words, if you do the inverse of it, is it still a function? So in order for the inverse to be a function, the original function must pass the horizontal line test. Notice it says the horizontal line test. If a horizontal line intersects the function's graph more than once, then the function is not one-to-one. All right, let's take a look at an example so we can make some sense of this. Okay, we know this shape is called a parabola, right? Remember this thing called the vertical line test. And so the vertical line test says if you put your vertical line anywhere along here, that it will only cross it in one place. Okay, so this is a function because it passes the vertical line test. Okay, well, what if we take that vertical line and we change it? Because now what we want to talk about is a horizontal line test. Does this pass the horizontal line test? No, because it's hitting it more than one time. The horizontal line test is the exact same thing as a vertical line test. We just flip our line the other way. So if this is a horizontal line, it's touching it twice. So that means that the inverse is not a function. So the inverse is not a function because of the horizontal line test. And so it is not a one-to-one. In order for it to be one-to-one, it has to pass both. It has to pass both the vertical line test and the horizontal line test. This one fails the horizontal line test, therefore it's not one-to-one. Let me talk maybe in a different way, and you can write this in the margin here. So do you remember we had these mapping diagrams? And we said that something like this, for instance, was not a function because this input had two outputs, so that's not a function. And then we said, but it's okay if it's something like this. Let's say we have something like this. This is a function, and I'm going to erase one of those sixes because, for instance, this 6, that's okay. That this one is a function because it can go this way, but it can't go this way. Well, if we're talking about one-to-one, it can only be straight across every time. There's no v's this way and there's no v's this way. A one-to-one function is just straight across every time. That's what makes it one-to-one. There's no doubling up in the x's or the y's. Doesn't matter which way you go. For one-to-one, it's just straight across every time. That is a one-to-one function. And so that's why this does not pass the vertical line test. Well, it does pass the vertical line test, not the horizontal line test. And it's not one-to-one because we have this point over here, which I didn't label, but let's say this is just like -5, 10, and this is +5, 10. Well, they're both 10. It's not one-to-one. Okay, let's look at this one. Let's think about the vertical line test. Vertical line test would work. That's okay. And if we talk about the horizontal line test, take this horizontal line test, it also works. So this function is a one-to-one function. And the reason it is a one-to-one function is because it passes both the vertical line test and the horizontal line test. That makes it a one-to-one function. Okay, next section. Do you remember I said that I made some mistakes on these tables, on these notes? So let's cross out this table. It's just bad altogether. And can we change this table instead to this table? And so take a minute, you might have to pause it here to write down this into your notes. The graph over here, I know on your paper, again, it's kind of hard to read. This says 5, 10, 15. Same thing on the y-axis, 5, 10. So there's our little tiny boxes in there. You probably can't see them on your paper. Again, my apologies on that. But let's go ahead and try to plot these points. So the point -3, -1 is going to be something like that. -2, +4, right about there. -1, +3, 0, 2, and 1, 7. And again, I know that these aren't real easy to read, so yours might not be perfect. I'm sure mine's not perfect either. But basically, this graph is going to go something like this. Okay, that's our original function. The question is, can you find the inverse table and then graph it? We did that, and now we're going to graph the inverse. Okay, so think about what we were just been talking about with inverses. Inverses switch the x with the y. So these numbers, -3, -2, -1, 0, and 1, are going to go into my y column. And in my x column, I'm going to put what used to be in the y's. Okay, so now I've put those into my table. Now I'm going to try to put that onto the graph. And so again, I know your graph, you can't see it very well, but we're going to do our best. -1, -3 is here. 4, -2, something like that. 3, -1, 2, 0, and then 7. And I'm going to have a hard time drawing this, but I will do my best. All right, I did not do a great job, I will give you that. But it's basically, if you're having a hard time with it, it's basically an S. I'm actually going to show you the Desmos here in just a second. Let me show you the Desmos. This might be a little bit easier to see. So the one that you were trying to draw just now was this blue S curve, and the original was this black curve here. Okay, so that's, you get a good idea of how it's supposed to look. Okay, so here we are. So the idea here is just that you are able to look at a table and come up with the inverse from the table, as well as graph those and see what they are. Now, a lot of times when I draw the graph, or even when I ask you to draw a graph, like on a quiz or something, I might ask you to draw a graph. I will also ask you to draw in the line of reflection. And so this line that I just drew, that's your line of reflection. It might help to see it with a dotted line. So here's the line of reflection with a dotted line. So again, all you need to know from this section is that a table switches the x's and the y's, and you then are able to graph that. You can look at the line y equals x and graph it within that line of reflection. All right, once again, questions, write down any questions in the margins, and then we're going to turn the page. Since I messed up so poorly on all of this, we're just going to cross out this section. It's just basically another example of the one we just did, but the values, I don't know if you can look at those values. We can't graph those values on the graphs that I've given you, so let's just skip it. The last thing is, are you able to look at a graph and determine whether or not it's an inverse? So let's take a look at the first example. The first thing I'm going to do when I look at this is I'm going to draw in that line y equals x. So here's my line y equals x, and I think you can see that, yes, this is an inverse of these two lines are inverses of each other because they do reflect in that line y equals x. So yes, they are inverses, and the reason they reflect in the line y equals x. If you wanted another reason, you could look at some of the points. So for instance, here we have a point 2, 1. That means we should have a point at 1, 2. And here we have a point maybe at 1, 0. That means we should have a point at 0, 1. And so we do. And so it does, all of the x's and y's are switched with each other. So yes, they are inverses. Let's look at this next one. Okay, let's say I draw in that line. Okay, if I draw in this line y equals x, is that anywhere near a reflection of it? No, it's not. So this one is not, and they are not inverses of each other. Well, for one, they don't reflect in the line y equals x. That's one thing. But also, they're just not even the same shape. That is, if you're going to have inverses of each other, they need to at least have approximately the same shape. These are not even close. And they don't reflect. Okay, once again, if I draw in that line y equals x, are these reflected in that line? No, they're not. Again, I hope you can see that those are not reflected in that line. Or if you wanted to look at some of the points, here we have a point 2 and maybe 1.5, which means that we should have a point 1.5 and 2, and we do not have that point, so no, these are not inverses of each other. Once again, if you have any questions, write them down in your margin. Also, take a minute to write some things down in the summary. Some things that you might write down is you might define one-to-one. And if you do that, write out the definition. Don't just write down what I wrote down here. I'm trying to now help you so that you know how to write a summary. So you should write down what is the definition of a one-to-one function. You might also want to write down what is the horizontal line test. You know what the vertical line test is, but horizontal line test is new. Another thing is we talked about three characteristics of functions. Three characteristics of inverses. What were some of those characteristics? What are some things that they switch from each other? How do they look? All of these things are things that you could write down in the summary. So write something down in your own words. These are some possibilities of what you could write down. And then that's the end of the video for today. So just bring your questions with you to class tomorrow.